Today's mini-lecture is covering Chapters 4 and 6. Chapter 4 covers aqueous solutions and Chapter 6 quantum mechanics. I chose Gatorade as my introduction image because Gatorade is an aqueous solution containing electrolytes that can transport electrons. On the right-hand side, you can see the University of Florida football player Chip who's testing Gatorade. Gatorade was formulated in 1965 by a team of scientists at the University of Florida at the College of Medicine. And Robert Cade and Dana Shirers were part of this team. After Ray Graves, who was the head coach of the Gators football team, Gatorade was created to help athletes by acting as a replacement for bodily fluids that are lost during this physical exertion of a football game. Chapter 4 has several important topics that you have to focus in on. First, Chapter 4 describes the general properties of aqueous solutions, including the electrolytes. Also, you will learn about precipitation reactions, and that has a direct implication on solubility, or how soluble solutes are, such as sugar in a cup of water, or salt in a cup of water. You will also learn about acid-base reactions and titrations. The chapter will also cover oxidation reductions, and you will have to understand oxidation numbers as well as redox titrations. You will also be reminded again of molarity, the concentration of solutions, and the aqueous reactions and chemical analysis of aqueous reactions. On the left, for example, you can see a precipitation of silver on a copper wire. On the right, you can see an oxidation reaction. There's heavy rust on a chain formed because of oxidation from air at the Golden Gate Bridge. Chapter 4 covers quantum theory and the electronic structure of atoms. Here you can see a picture of the major fathers of the quantum mechanic theory. This is in 1927 at the Solvay conference. Can you find Einstein? These are the important topics to hone in on Chapter 4. The nature of light, quantum theory, including the photoelectric effect and black body radiation. You have to understand Bohr's theory as well as wave properties of matter. The uncertainty principle and the Schrödinger equation have a direct implication on quantum mechanics as well as quantum numbers and atomic orbitals. You will also learn electronic configurations and the periodic table again. Basically, in Chapter 4, everything has to do with light as well as particles. Here you can see a diagram of the electromagnetic spectrum showing the various properties across the range of frequency and wavelength. As you can see, going from left to right, radio waves are lower in energy than gamma rays. And this has a direct implication on temperature as well as on frequency. The smaller the wavelengths, the higher the frequency, vice versa. So here are some examples of some quantum theory. So on the left you can see the photoelectric effect, which basically is a photoemission, or the production of electrons or other free carriers when light is shown onto a material. Electrons are emitted in this matter and they can be called photoelectrons. On the right you see black body radiation. Black body is a body that absorbs all of the incoming light and does not reflect any. So therefore, at room temperature, such an object would appear as perfectly black, such as going from the left to the right. The Schrödinger equation is a partially differential equation that describes how the quantum state changes with time. And here is the Schrödinger equation. Finally, the Heisenberg uncertainty principle states that the position and the velocity of an object cannot be measured exactly at the same time, not even in theory. Now, in order to apply these concepts that you are learning in Chapter 4 and 6, you should really check out the PowerPoint presentations that are in your modules by McGraw-Hill. Each topic is accompanied by sample problems, such as one seen here. And in the last chapter, we taught you how to solve problems like this. First, you do a strategy, set up a strategy. Then you set up the calculations, and then finally you come to the solution. But the most important aspect of solving a problem is that at the end you should think about the solution if it makes sense. Finally, you learned in Chapter 4 about aqueous solutions, and in Chapter 6 you learned about quantum mechanics. The question is, how are these two concepts related? Because they seem so different. Well, in chemistry, there are many topics that are actually relating these two concepts. Electrochemistry, for example, solves quantum mechanical equations for transfer of electrons in aqueous solutions that go across solution interfaces. This reminds me of when we used to think that we had two different worlds, and finally we were able to figure out 2 + 2 = 4, and we're really just one world.